Well, the weather outside is frightful, but the math is so delightful. We're actually ready to start our second chapter together on logic. And while I hoped to be with you in person to start that, I appreciate your patience and understanding during these extenuating circumstances. I don't intend to make an 80-minute video here, but I do want to start the conversation about it, because I feel like this is an important conversation to have. I don't know if you've ever had the delight of having a disagreement with a 5-year-old, but it generally goes one of two ways. Whenever you inform a 5-year-old child about something, you're either going to get blind acceptance, which is how I was as a child. If you just told me anything, I would just believe it, no questions asked. I remember being a kid, riding in the car with my parents, and I saw a sign that had the letter P, and had a red circle with a line through it around it. I remember asking my dad, hey, what does this sign mean? And he was like, well, it means no peeing. You can't pee here. And 6-year-old me was just like, thank you, I have no follow-up questions. Actually, I had a lot of follow-up questions. It was like, did Jackson have just a rampant public urination problem? Because those signs were posted every 10 feet, that tells a story of probably just one person who is urinating somewhere, and the cops are like, hey, you can't do that there, and he's like, I don't see a sign, and they're like, there's one right there, and he's like, what, all the way over there? That's actually more interesting might be the places where there wasn't a sign. I think I have more questions about those places. Anyway, you're either going to get blind acceptance, or you're going to have someone who will not accept anything that you have to say, no matter what. Just a bold confidence that, frankly, I'm a bit jealous of. And I had a conversation like that with my daughter just a few weeks ago. It was over the Christmas break, and she walks into my room and just says, today's Friday. Which sounds like an odd way to begin a conversation, but when you're 5, there are no standards of how you begin a conversation. In retrospect, it's probably the way you begin a conversation if you just had a disagreement with your mother about what day of the week it was, but at the time I thought nothing of it. So I just responded, oh, no, sweetie, it's actually Saturday. To which she says, no, it's Friday. I'm telling the truth. And at this point, we have a conversation about how you cannot be lying, but still be wrong. And she's like, no, you're wrong. Okay, shots fired. So I pull out my phone. I'm like, hey, have a look at this, right? It says the day of the week right here on the phone. And right there, it says SAT. You know what that's short for? She goes, Friday? I'm like, no, I love your confidence. It is indeed short for Saturday. I say, hey, how would you go talk to your bestie, Alexa, the keeper of all human knowledge? And so she goes upstairs and asks, Alexa, what day is today? And I can hear Alexa responding, today is Saturday, December. We have her on Australian, which is the right decision. She comes back down, apparently Alexa's in on this conspiracy, just standing her ground. And this prompts an ontological, philosophical discussion of, how do we know things? How can we experience truth? And so I ask her, how do you know that today is Friday? And she says, because yesterday was Thursday. Okay, we're getting somewhere. I see the deductive reasoning. We're getting somewhere. Okay, how do you know that yesterday was Thursday? And she goes, because today's Friday. Okay. I don't know if you've ever had the joy of having a conversation like that with a 5-year-old. Maybe you've had it with an adult. Maybe you've been to the comments section on a YouTube video. I don't know your life story, but I bet that at some point in your life, you had the thought that there needs to be some ground rules on how we think. There needs to be some basic principles of how we're allowed to reason and come to conclusions. And you're right, we do need that. we do need some ground rules on how you think, because without that, if there are no basic principles or fundamentals of thinking and thought, then we can't know anything for certain. Now that's a really big statement, but it's true. If we don't have any rules that we agree upon about what's going to constitute good thinking, what kind of thinking is correct, and what kind of thinking is incorrect, then we can't reach any conclusions, and you can't know anything. And so this conversation might be more important now than ever before. In the age of deep fakes and plagiarism and AI generation and fact-checking and just a world full of misinformation, maybe now is one of the most important times to have the conversation about how can we actually think correctly? How can we reach true conclusions? And that is partly a mathematical conversation. Good thinking has two components to it: correct facts and correct reasoning. And in a perfect world, we'd get to study both of those to their fullest extent, but for the most part, I'm focusing more on good reasoning. That's what the laws of logic are going to focus on. If we want to talk about getting good facts, making sure that the facts we see are true and trustworthy, that is a whole other conversation about where we get facts and how we determine whether or not something is true. But the laws of logic are more geared towards that latter part of the conversation. Assuming that we can start with trustworthy facts, how can I draw believable conclusions from them? How do I reason? How do I take my list of facts and use them to arrive at some sort of an action that I should do or a belief that I should hold? How do we get from start to end with that correctly? Now, part of this is built in you. It's like part of you. There's part of your brain that can acknowledge that some forms of reasoning are bad reasoning, and you can pick some of them out. Like if I were to say something like this to you, if I were to say something like, all dogs are mammals. Some mammals are cats. Therefore, some dogs are cats. There would be a part of you that's like, I don't think that's so. And maybe you can identify what part of that reasoning is flawed, or maybe you can't, but you're just like, I can't put my finger on it, but I don't think that quite follows. There's still something in you that can recognize when reasoning is not good reasoning. And what we want to look at in this chapter is, how do we recognize good reasoning? How do I identify bad reasoning? How do I think well? That is the goal of this chapter. How do we think the way that we're supposed to think? And I'm excited to share that with you. Since we're going into a new topic, the natural foundation for that is going to be the foundation for any topic or field in mathematics, and that's definitions. So let's start with our very first definition. Boop, 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 woo! And if you didn't make the sound, you can always rewind it and try again. Nice thing about video, unlimited chances. Right, the definition. We're going to try this little circle thing. It's my first time. It's pretty exciting. Anyway, definition. Boop, 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 woo! A statement is a declarative sentence that is either true or false. The basis of all logic is a statement. That's all that there is to it, right? If we're going to try to make an argument, well, how do you make an argument? Arguments are made up of statements. But what's key here is that by a statement, it's a sentence, a declarative sentence. It's declaring something, but it has to be something that's either true or false. And that value is called the truth value of my statement. If you give me a statement that's true, it's a true statement. That's its truth value. You could also make a statement that is false. Let me show you some examples. Oh, didn't know that would work. Okay. Here's an example. I have blue eyes. That is a statement. It is a declarative sentence that is either true or false. And now we can talk about whether or not it's true. Probably hard for you to tell real far away, but I do have blue eyes. They're very blue. So yeah, it is a statement and it is true. Here's another one. I am 17 years old. That is a statement. It is a declarative sentence. It is either true or it is false. In this case, it is false, though it might be rather hard to tell just by looking. How about this one? One of my dogs is a Bernese Mountain Dog. That is a statement. It is a declarative sentence that is either true or false. For each of these, we are able to say, yes, this is true, or no, this is false. And in either case, that's what makes up a statement. All of logic relies on our ability to look at statements and talk about whether or not they're true or false. In this case, that statement is true. I do have a Bernese Mountain Dog. It's possible that at some point in the video she'll lay down on this bed behind me, but there's no guarantees. She's unpredictable. How about this one? Close the door. That is not a statement. That is a command. That is not a declarative sentence, that is an imperative sentence, and it's not a statement. I can't say it's true or false, right? You can't be like, close the door, and I'm like, false, right? It doesn't work that way. How about this one? Are you wearing shoes? Not a statement. It's a question. Now, maybe you could answer that question by saying yes or no, but the statement itself isn't really a true or false thing, right? I can't say, are you wearing shoes? And you could be like, true. Like, maybe you could say, yes, I'm wearing shoes, but the question itself is not something that's true or false. Your answer to it would be. How about this one? Ah! Not a statement. That is just a scream. It's an exclamation even, like, oh my! Oh my is not something that is true or false, nor is ah. How about this one? Game of Thrones had the worst ending of any television series of all time. Not a statement, because it's an opinion, right? It's subjective. Now, you might believe in your heart that that is true, but somebody else might disagree and be like, nuh-uh, How I Met Your Mother had the worst ending of all time. We can all have our own opinions, but that is an opinion. It's not something that's objectively true or false. The color of my eyes has an objective truth to it. There is a definition for what it means to be blue. And what it means to be the worst ending of all time, we don't have a metric for that. How about this one? This sentence is false. Somebody actually asked me about this once because it appears in the game Portal 2 near the end of the game.
Hello?
Alright, paradox time. This sentence is false.
True. I'll go true. Yeah, that was easy. I'll be honest, I might have heard that one before though, sort of cheating.
It's a paradox. There is no answer.
Is that a statement? No, because a statement has to be true or false. And while this is a declarative sentence, it's not a statement that's true or false. This is actually an example of what we call a paradox. And a paradox is a mathematical statement or problem that is both true or false in a sense, or neither true or false. The technical definition is that a paradox is a question or a statement or a problem where there are two contradicting solutions to it that are both logically valid. And here you could make the case that that is a true statement, but you could then equally make the case that it is a false statement. So it's a paradox. It's not true or false, and therefore it's not a statement. Oh, that works. Oh, lovely. Here's another example for you. The integer x is an odd number. Is that a statement? Well, no, it is not, because I can't know whether it's true or false until you tell me the value of x. With that variable in there, I have no way of knowing whether this is a true statement or a false statement. If you told me the value of x, then I would be able to give you an answer, right? Like if you were to say that x was 5, then I could say, oh yeah, this is a true statement. I can tell you whether 5 is an odd number. It meets the definition, so yeah. But if you were to tell me that x was 6, then I could say, oh no, that's a false statement, right? It does not meet the definition of being an odd number. And so this is kind of an interesting scenario where I've got what could be a statement, but it's got this openness to it. It's got this variable that if you were to tell me the value of the variable, I would be able to tell you whether or not the sentence is true or false. This isn't a statement on its own, but we call it an open sentence. It's a sentence that has some kind of an unknown piece to it, like a variable, like an x or something, and if you tell me the value of the variable, then I can tell you whether or not it's true or false. That's really all there is to the concept of a statement. It's a sentence that's true or false. And sometimes we use open sentences, where if you give me a little bit more information, I'll be able to tell you whether it's true or false. We'll get back to those later when they become a little bit more relevant. But before that, I want to talk about notation. And notation is an important part of mathematics because it's one of the ways that we communicate, just like we do in writing, and just like we do when we talk. If you've got something that you want to talk about, you give it a name. And if you got something that you want to talk about a lot, or very specifically, you give it a nickname. Like when I tell my daughter we're going to the library has a name, right? I don't have to tell her, hey, we're gonna go out. And she's like, where are we going? And I'm like, well, there's this building and it has all these books and you can just borrow them for free. Like up to like 70, it's kind of ridiculous. I don't have to do that. I can just tell her, hey, we're gonna go to the library. You got something you want to talk about, you give it a name. There is more than one library, so she might ask, which library? And at that point, well, our libraries have nicknames because she's 5, and right? I mean, I can't be like, oh yeah, we're gonna go to the library down in East Grand Rapids, right off of Breton, down by Gaslight Village. That's not gonna work. Although I love that Gaslight Village is a real place. It cracks me up. Whenever somebody else brings it up in conversation, I try to convince them that it's not a real place, just for me. My wife loves that game. She'll be like, yeah, we'll just get it down in Gaslight Village. Don't. I'm like, what? Like, do not try to convince me that Gaslight Village doesn't exist. Would I do that? It's like, yeah, you do it all the time. Like, I'm pretty sure I never do that. But in this case, if she says which library, I might say the Happy New Year Library, because she went to some New Year's event there like 3 years ago, and that's what she calls it now. You got something that you want to talk about, you give it a name. You got something you want to talk about a lot, you give it a nickname. And in math, and in most fields, if you've got something you want to talk about, you give it a name. You give it a definition. And if you got something you want to talk about a lot, or if you got something you want to write about, you give it a nickname, or notation. We come up with a symbol or something so that we don't have to write it down each time. That's all that notation is in math. I use the letter X because I don't want to have to write the mystery number every single time. It takes a lot of space and time. It's a lot easier to just say, hey, there's some unknown thing, call it X, right? That's what we want to do in general. And since statements, declarative sentences, can get pretty long, I'd like to give some notation to them too. The notation that we use for statements is actually a very simple one. We usually just use a single letter, like P or Q, and then we'll put like a colon after it to say, okay, here I've got a statement P, and here's what it's going to be. And maybe it's P is the statement, I am wearing yellow pants. That is a declarative sentence that is either true or false, and you will have to just imagine what it would look like for that statement to be true right now. Maybe I've got another statement that I want to refer to. We'll call it Q. My dog is covered in fur. That one is true, objectively. And so now I can refer to these statements P and Q by just their letter. P now stands for that whole sentence, so I don't have to write it every single time. And Q just stands for that whole sentence, so I don't have to write that every single time. when we start talking about making an argument and putting several statements together, being able to write just a single letter for it is going to be a really huge and important idea for us. It's going to make it a lot shorter. Because, just a little preview, arguments don't necessarily come down to the very specific statements that are involved. It's usually more about the structure of how statements are put together. And so it might not always even be super important what exactly the statement says. It might be more about how we're putting statements together and how we're reaching a conclusion based on them. So being able to use just a single letter, pretty clutch. When we're talking about statements, there's a common piece of structure that comes up called a truth table. And if you're using the notes templates that I have up on Canvas, you'll see that heading next in the notes, truth tables. I'm actually going to call a little bit of an audible here, and I want to skip over that for now. I want to come back to it in a little bit, because if I try to describe it to you now, it's not going to make any sense. I'm going to wait until I actually want to use it for something before I talk about it. So for the moment, I'm going to keep moving forward to the next part of the conversation, and we'll talk about truth tables in a moment. The next conversation to have about statements is, well, what can I do to a statement? And then the conversation is, how do I put statements together? Kind of like numbers, right? What can I do to a number? I can square it. I can square root it. Just options out there, right? And then there's the conversation about how do I put numbers together? Well, I can add them together. I can multiply them together. Both of those conversations matter with numbers, and both of those conversations matter with statements. There's really only one thing you can do to a single statement that's worth mentioning, and that's the idea of a negation. Let's take a look at some examples, including this first one that makes me regret not looking ahead at a slide a moment ago. But if P is the statement, I am wearing yellow pants, then the negation, not P, I am not wearing yellow pants. The original statement P in this case is false. I am not wearing yellow pants. I do not own yellow pants. I don't think I know anyone who owns yellow pants. If any of you have yellow pants, let me know. Write about it below in the comments. But the negation of that, I'm not wearing yellow pants, is therefore a true statement now. They're both statements. Only one of them can be true. Whichever one is true, the other one's false. Here's another one. Here's the statement L. The Lions won the Super Bowl last year. Oh, geez, too soon. That is a statement. It is a false statement. The Lions did not win the Super Bowl last year. That would be the negation then, right? Not L. The Lions did not win the Super Bowl last year. It is not the case that the Lions won the Super Bowl last year. And yeah, I am realizing right now, live, that Super Bowl is not one word. And apparently Pat Stephen was pretty convinced that it was. Here's one more. The statement D. I don't own a dragon. Now this already has that negative in it, right? If I were to follow the previous pattern here, I'd say, I don't not own a dragon. But that double negative will undo each other, right? And I'll get this negation, not D, is that I do own a dragon. In other words, the negative of a negative takes you back to the original, right? If I were to have not P, can I write that? I'm sure I can. Right? Not P is equal to P. They are the same, right? Double negatives will undo each other. And you're used to that, right? You hear people talk that way. Maybe you've called people out on double negatives in cases. I remember hearing a NASCAR driver one time at an interview say something like, we don't have no reason to not be afraid of them. And I was like, wow, that is a triple negative. He slipped up and said what he meant. Now, if you're wondering what kind of nightmare would lead us to be working with negations of negations, well, it's not as uncommon as you might think, because we talk that way sometimes. Sometimes on purpose, because sometimes the way that you say something can communicate a different connotation based on how you say it. A while ago, I had a student who was coming by my office to take a test outside of my office, and I gave it to him, and it was typically like a take-home test, so I expected that they would probably leave and drop it off later. But I handed it to them, and I said, hey, I'm gonna be here for the next hour if you have any questions or if you want to turn it in. And they said something like, "You really think that I can finish this in an hour?" And I responded with, "I don't think that you can't finish it in an hour." And that's a double negative. But it means something different than just, "Yes, I expect you can finish it in an hour," right? If I were to say that, "Yeah, I think you can do it in an hour," that makes it sound like I expect that, right? Like that's the default. "Yeah, you should be able to do this in an hour. And you're a silly goose if you can't." But that's not what I meant, right? It was more like, I don't expect you to do it in an hour, but you're an intelligent young person. I wouldn't be terribly surprised if you did finish it in an hour. Totally different connotation. And when we're talking about logic and statements, we need precision to be able to distinguish between connotations. And so we want to know when those kind of statements are the same. That actually feels like a pretty good spot to wrap up for this video. We're just barely getting into the introductory pieces, but I feel like it's a good start. We've got this idea of a statement, a declarative sentence that's either true or false, and we're moving into the conversations of, well, what can I do with that? Right now, the only thing we can do with it is talk about its negation, the opposite of it, the not version. And we'll settle the remaining pieces about it, including talking about truth tables and all of that business when we reconvene on Thursday. Thank you for joining me in this, and I hope you have a very wonderful day. Feel free to reach out if you have any questions, and I hope that the weather on Thursday will permit us to meet again. Until then, adieu.
Give me your attention.